All right, well, thank you everyone for coming on Easter weekend, and especially on such a nice day. We're really excited about the two finalist projects today. I'm pretty sure everybody in the room knows what's been going on, but just to recap the project, HIVE City is a competition that the Ecological Practices Group has been organizing to basically design a bee habitat installation to house an existing bee colony at Silo City. The competition is being generously sponsored by Rick Smith and of Rigidized Metals, and it's been a real blast so far with this this whole process. This is the third and last competition phase of this process. In the first phase, which happened in early February, the students, 10 student groups signed up and went through a 24-hour charrette. In the second phase, 4 student groups were selected out of those 10 and presented in this room schematic design proposals. And this is the third and final phase of the competition process. You'll be seeing projects that are developed in a lot more detail, which will include budgets. So it's quite detailed. And maybe I'll hand it over to Chris to talk about this phase, and then I'll introduce the jurors again.
So in the last phase, which lasted about the last 5 weeks, Martha and myself have been working with the two student teams to develop, continue the refinement of the design, which was pretty much fixed when we had the last jury about 5 weeks ago. Martha kind of led up working on what we dubbed the hiveability, so how well the kind of environmental systems or how well the shelter would actually support the bee colony. I worked along with Mark Bajorek, who's a project engineer at Systems Engineering out in Amherst, on the two-part constructability was one, and second, working through simple structural diagrams, and second, starting to put together a budget. So what we did that, we had both groups visit Rigidized Metals just a few days ago to get a sense of material costs, fabrication costs, and what ultimately we could put a very preliminary number on the schemes to give Rick a better idea about what you're in for. And that constitutes on the wall, which maybe we'll focus on a bit more when we move into the private jury session, but a series of 2 PowerPoints each team has put together that will last about 15 to 20 minutes of presenting their scheme, and then equal that 15 to 20 minutes of a Q&A session from both the jury and anybody in the crowd who wishes to ask a question of clarification regarding any piece of their design. So I will hand it back to you.
All right, thanks, Chris. Okay, so for today's presentation, the jury consists of Rick Smith, the head of Rigidized Metals in Silo City, Jim Watkins, the site manager at Silo City, Philip Barr, the beekeeper, who's also been advising the students along the way, Bob Shibley, Dean of School of Architecture and Planning, Linda Schneekloth, Professor Emeritus of the Department of Architecture, who also brought this competition to our attention, in fact, Omar Khan, Chair of the Department of Architecture, and Brian Carter, where's he? Brian Carter, Professor of Department of Architecture. Also, we will be sending the drawings to William Haskus and Peter Dorsey, who are architects in New York, and they will be commenting by email. Chris mentioned a lot of people who worked on the project, but also other advisors have included, another advisor included Alec Poklinkowski. I don't know if he's here, but he's a student in the Department of Architecture who's been helping out with some of the hiveability issues as well. So with that, I will hand this over to Team 3, the tower team of the Department of...
All right, thanks everybody for coming. We're Team 3. We worked on the tower project. My name's Courtney. This is Lisa, Kyle, Dan, and Scott. So for our project, Rick's generously sponsoring it, but we're designing for bees. So we've really tried to keep that, and you'll see it in later drawings, but we've really had that at the forefront for our designs in addition. And so these are just kind of conventional beehives for what we think of. As when you think of a beehive, it's either in nature or kind of the standard like pine boxes that are just kind of left out in the snow. But with our project, but with our project, we're striving not only to make it functional, but to make it a beautiful object. And not only that the bees are coming first in our project, but we're also trying to create kind of an iconic design for the site. So this is Silo City, and as part of this redevelopment project, the bee tower is kind of the first phase in this redevelopment. And so for our concept, we're trying to emulate this action that you have to take to actually occupy one of the grain silos in Marine A. You kind of have to crouch down and then go into one of the bins for the silos. And then once you're in there, though, you look straight up and you kind of realize the height of these things. So that kind of motion is what we've been emulating in our project. This is our general site, and you can see here the wind comes from like the southwest off of the lake. Our human entrance is on the south side of our tower, and the bee and the beekeeper access is on the northeastern side of the tower, similar to where it is now in the office building. So our tower is 22 feet tall, and it has this aggregate of panels across that accommodate for wind and for the sun, for solar gain and to allow wind to pass through it. And so kind of a general diagram, you can see on the south side and the southwest side, that's where the prevailing winds come from. So we wanted to have as much porosity on those sides as possible, and then also to allow for solar gain during the winter. There's more holes punched into our panels there to allow for that. So if you unroll the elevation of our tower, this is kind of what you get. And on the south and southwestern side, the holes are much more dense, and as you work your way around to the northern side of the tower, then it becomes a lot less porous. So we've been playing around, especially after we talked to Rick and the guys at Rigidize the other day. The first one was done with a grasshopper script, making unique panels, and with this you get the same effect, but with only 6 different panel types. For just production ease, it is probably a smarter idea. And our various cut sheets that we would have to be working with at Rigidize, they're all 3 by 10 foot sheets.
So this is a series of plans cut at different heights, just showing the different zones of the tower itself. At the bottom it shows the 2 entry conditions, one for the beekeeper and one just for viewing purposes. And then the next plan shows the cab being raised, and then the top of the cab structure with the bracing, and just a general roof plan just showing the position of the cab in relation to the rest of the tower. And this is just a blown up detail of a few plans showing the structure of the bee cab itself and the structure of the tower with panels attached to it.
Here's just basic sections through our tower showing the condition of the tower up and the condition of the tower down. The tower down is mostly for the beekeeper to access the bees and for educational purposes. Dan will go in more detail how that works. For the bee cab, we decided to add a few elements from last time. So it's 1.5 inch thick cypress board. There's a 45-degree cut for viewing purposes up. The glass is 1/4 inch tempered glass or 1/4 inch laminated safety glass. We could price both and compare the prices. We added linear boards to allow the bees to grow, because from our understanding of meeting with the beekeeper, they like linear aspects, so we wanted them to have more surfaces to grow on in our cab. So it's basic wood connections, and then we have connection details, how it meets our mechanics.
So with the added height of our tower, we decided we need to sort of increase the strength of our foundation system. So what we have basically is the steel now is welded to a plate, which is attached to a concrete cylinder, which in turn is cast into a buried slab. And the 3 feet of earth on top of that increases the resistance to the overturning moment, and it also allows for the connection to be hidden.
So these are some of the details on how the tower would be constructed, the structure. And I guess some of you guys haven't seen this at all yet, probably. But it'd basically be a steel frame structure. But it's basically hexagonal in nature. But we basically wanted to make everything out of just standard sections. So it's actually made out of 1.5" steel tube, and then the corner details is a 1.5" steel angle combined with a 3/4" steel angle to make that 120-degree bend that it has to make at the corner. And there's actually only like 4 unique pieces that have to be cut to assemble this whole frame. It's, there's a lot of pieces, but they're actually kind of standardized. And then this also shows the connection detail to the rigidized steel panels. This isn't necessarily the pattern we're going to use, and it's not perforated. It was just what they had laying around the other day. But basically what we'd be looking at is attaching it with 1.5" stainless steel cap screws with a 1" nylon spacer to separate it from the steel frame. And so here's a photo of that, the corner detail with the 2 steel angles welded together to get that 120-degree angle. A little closer on the model, and then these are diagrams of how the B cab moves up and down.
Right. So we had a couple ideas in mind with this. Basically, you have the runners are above the V cab itself, and then there are the connection to the actual structure is flanged bearings, Teflon. And the whole reason for this was to, since our structure avoided on like opening up or concentrated on opening up our corners with the hexagonal structure, we didn't want runners going all the way down, so we decided to add the runners on top of the cab. And this also makes use of the vertical space. Since our tower is 20 feet tall, it sort of justifies that height, and we had that height to work with. There's a couple other features. It's in locked position. It's more sturdy when it's in the upper position, and then in the lower position there's more play. The tower also, it avoids the use of wheels, which might be difficulty with the corrosion and like weathering. One of the key features too is the load is applied at 2/3 the height, which is important too for, instead of being suspended from the top of the structure, it is now suspended from 2/3 the height. Couple other notes. So the flange bearings are welded to the frame on the side, and basically here's the detail of it. Scott, you want to explain?
Yeah, so basically the cab is hanging from some 3/4" steel rods that are located at 4 corners of the cab. The corners of the 2 long faces and the 2 short faces, part of that is basically because of the center of gravity of the cab. It's, the cab's asymmetric, so, it made more sense to go to those 4 points to help support it. And then, so you see that this is basically the connection to the cab. Steel rod would be welded to some straps that would anchor into the cab at each rod at 2 points. And then up here, this would be the Teflon flange bushing that then this is the rod moves up and down through. So there's actually 2 sets of these Teflon bushings for each rod to keep the cab moving straight up and down. And then this is the connection detail for the steel tube structure. And then, you know, here's the same thing sort of in plan view. And then these are just some details on the winch that we found. So the cab weighs with the bees under 300 pounds. So we found a winch with 3/16-inch steel cable that would be suitable to move the bees up and down. It's actually fairly inexpensive for a stainless winch. It's about $300. So, you know, these are some shots of the model and just kind of, you know, showing some ideas of what the tower would look like. On the left is when the bee cab would be in the lowered position for the beekeeper to access the bees through this door, which also has these holes in it for the bees to enter when it's, you know, in the raised position more up in this location. This is sort of a, you know, a model shot, some Photoshop looking at how, you know, how the beehive would look when you're in the tower looking up at it. And then, you know, sort of what we call the bee's eye view of the tower as they're sort of like flying into home. Another kind of shot looking at. And then I guess this is maybe the least popular part of the presentation, maybe the budget. But we were pretty rigorous about, you know, breaking everything down and really looking at the costs for, you know, everything from the foundation to the structure to the skin, bee cab, and then mechanics. You know, but the steel for the structure, you know, is under $1,000. I mean, that was up, you know, we kind of wondered like what that would actually come out to since we're building a 20-foot tower, but it seems like it's actually a pretty efficient use of steel. And then by far, you know, the biggest item is the rigidized panels. And, you know, that, it's kind of a, so, I mean, I don't know if we need to go through every line item or we can do it, you know, if you guys have questions later. But basically, so we looked at, Courtney mentioned earlier, you know, the first idea was the model with the 66 unique panels. We were looking at just for those panels was like $19,000 or something like that for rigidized. But dropping it to six panel types, which actually gives us 12 options because they can be flipped upside down, you know, knocks like about $10,000 off. And so the total without the rigidized panels, all the other materials, structure, mechanics, BCAB, is about $3,000. And then so the balance of that is rigidized. And it was both, we had both material and fabrication costs because our panels were pretty much all set to go. Like, so we got not just the material cost in there, but the fabrication cost for rigidized as well. And then, you know, this is an idea of kind of what it might look like in the site once it's built there, and grow some flowers around it. I think that's it, right? Ready for any questions?
Like opening up.
For any kind of questions anyone has. These guys want to show you something outdoors. So maybe, I mean, the model, we'd actually go, you know, when the bee cab's in the upper position, there would actually be a strap, like a hinge steel strap that would actually hang across the corner and lock in position so that only the beekeeper can lower the bee cab. And we'd actually probably also build a box that locked over the winch just so, you know, people can't come and mess around with the winch. But, you know, basically the winch would be located, so this is the door that the beekeeper would enter. This is the door the public enters. And so the winch would actually be located just inside the public doors of the light. And you'll see why when it comes down, because it's kind of basically for clearance for the winch. So the beekeeper would basically, you know, could reach in, and the winch would be located here, reach in with the right hand and lower the bee cab. And then would have to just walk around to the
your choice for the materials of the V-cab, you're basically replicating what is existing now. You have glass for the viewing, and then you have what did you say?
Cypress. That's what we were understood he's like for that. And it's supposed to be weather on.
Yes, cypress is, I mean, it's a good wood to use outdoors.
And we have metal roofing on top of our cab, and there's a plastic cage, so it'll shed water because it's open.
Yeah, so that was sort of a change in this design from the last review. The last review, we had a roof sort of on top of the tower, and it was enclosed with steel and glass, sort of the whole thing. So then, we went to the idea of the perforated panels and basically only really weatherproofing the V-cab. So, it's actually seemed to make a lot of sense because they're, the mating and the fence all that. And even if it was raining and somebody was standing under the V-cab, they're not going to necessarily be wet.
So when it sits on the ground, I'm just curious about what that detail is against the ground, because we have to hide now in kind of surface that it could be attaching itself to pretty easily.
Yeah, the runner actually stops it. The top part of the runner stops it before it hits the ground, so it's suspended 2 or 3 inches.
So the tower is suspended off the ground. So there is a
Oh, no, the cab.
Yeah, itself.
The V-cab.
Oh, the V-cab.
You just have the
Oh,
foundation.
Yeah. I'm sort of curious about the
The panels will probably be slightly off the ground. I mean, so
So we have the structure kind of continuous into the ground. We wanted to have that connection between the structure and the foundation, so it would kind of be filled in, and then the panels would go slightly above.
So what you see at ground level would be just the structure of steel.
I know it's a very short time. Could you do any kind of study to try to understand what the wind infiltration would be and how that actually would be, how the wind would be moving through it? Because when you have wind coming on one side, infiltrations on the other side, it changes a lot in terms of the dynamics. And so I'm just curious to know how this thing would affect the wind both on the outside, which would speed up, and the inside, that would, diffuse.
Didn't really have too much time, obviously.
I know.
The last study. But I guess if I had to make a guess, one of the reasons for having the open top and perforations is during the summertime is to heat up quite a bit. So you're thinking we could probably get a little bit of a stack effect rising out of the shed for summer.
In the perforation, it's kind of a composite with the wind and trying to allow for solar gain during the winter. So the bees aren't getting frozen out there. But we haven't really gone through and done exact number calculations and analysis yet.
Is there any insulation around where the hive itself is? Because, one side would be, like today, one side would be really hot and one side would be really cold. And it's curious as to whether or not you thought about how that would.
Yeah. Well, we've kind of been treating this like just the regular kind of box beehives, where those boxes just kind of sit out in the elements, and so that's why we went with the wood for the actual hive. But we haven't.
And I mean, the whole bottom face of our V-cab is glass, so putting insulation into the walls of it is in some ways you're not going to necessarily be a lot anyways.
Yeah, I was just talking about the exterior structure, not on the hive itself, but around the outside. And then I was curious about whether the wind, if you actually opened up some of it so that it wasn't quite so solid, if you actually might get better wind flow so that you could see the structure exposed at some point and not really. I'd just be curious to know how that would work, the whole way the wind might function.
Yeah, and actual drawings with an elevation, the structure comes through a lot better. I think it's just
Actually, the model photos too would actually go and show through.
Yeah.
Yeah, so getting back to that, that's like just a model photo, but and you start to see the structure through the scan, which is like, it's what we always hoped for, but it was sort of anticipated. But you didn't see it
So be friendly.
Be friendly.
So what is the finish on the last one?
This?
Yeah.
So the finish, this isn't actually representative of the material we'd be using. It's basically going to be stainless. We can tell you it's a 5 W well, I think, one of the
Yeah, it's a
standard
5
rigidized. It's 18 gauge rigidized stainless. But actually, this is actually a pattern that one of the guys at Rick's shop suggested we look at as well. It's a little bigger than what we were looking at as far as the size of the nipples in this case. But they suggested that the light diffusion might be better. So, I mean, I guess we're sort of.
We would need to actually get samples cut and run some tests and see how it looks, if you do it.
But we've got, we've actually got samples of both material. It was just easier in their shop. We went in Thursday to get some material to make this, and it was just, scrap it. And this is actually aluminum, not stainless.
We can do as many mock-ups as we did for the Javison. We have a performance mock-up and a visual mock-up. Mock-up of the mock-up.
And the interior structure is what's the finish?
That would be good.
The other thing is the doors. Are they meant to be open all the time?
Yeah, the only door is the door of the beacon itself, which is, would be still.
And the piece here.
Okay, would you like it? Project.
I don't know how this piece would.
Lighting.
Yes, we would like it. I don't know.
Isn't something we really talked about.
I would suggest it. You wouldn't suggest it?
Yeah.
I mean, you could up underneath if that's yeah, I mean, in some way or another. I don't have an idea about how to do it, but I just looking down to. Oh, no, there's a bench putting lights inside the cabin on with that. Yeah, I don't know.
You showed a really nice picture of the landscape, but I didn't show how people might approach it, or they're not supposed to, or they're. I mean, I'm just curious as if you're actually guiding people to come in and see this, or if you're just having it happen.
When we started talking to Peter and William, who are the architects that Rick's been working with, they had been kind of doing some site master planning too. So the idea is this is kind of the general location, and there would be some sort of sculpted path that goes along the whole rail bed that's there. That's kind of that sweeping arc. So there'd be some sort of path there, but it's still kind of under consideration.
The landscape architect's in charge.
Jim's bought an acre of wildflowers, so he's just going to spread them.
We have a couple more minutes, so any other last questions?
I do think the lighting is an interesting question as far as, if it were to be a beacon that wants to beckon people to the site, there may be some consideration given to, that it's a huge part of what this project is, but it could be something that we should consider. As it is the first sort of intervention on the site, coming from Ohio Street to actually see that there is something that's there, and as volcanic as it is, as a power that may, depending on the thing, but I think your choices of material are good. But you will be able to
less wind versus a winter with less heat, more wind? Like how the preparations will go when you tell how they'll contribute?
I mean, I'll comment about some of the other the preparations, but I think you look at that more with the angle of the glass, the angle of the bottom, and blocking out late in the summer, and then allowing it in the winter. It's a 45-degree cut, so maybe between the equinoxes, that's where it sort of start to block out like a little bit. So hopefully let in some more sun in the winter to heat a little warmer.
And we do about that will be our final stat is to do the exact wind and solar calculation.
How did you decide on the scale of the preparations? Did you do any studies relative to different scales of openings?
Part of it was the size of the openings that these like to go in.
Yeah, we couldn't go smaller than an inch and a half openings because then bees will start to fill it in themselves. So we had to keep it above that amount. And then once we started punching holes in it too, we didn't want it to be too spacious because then you start taking away too much material, and then there's a possibility for the panels themselves to be kind of floppy on the structure. So it was kind of a balance of those two.
And we had done some studies too with actually where the triangles were different sizes, so they got bigger and smaller. But then decided to go to kind of one size. And we were especially after primary study, which is trying to make this more uniform panel type. With there's basically a great the 6 panels that we've come up with now. There's what it starts at there's one that's 0% punched out, and then 10%, 20%, 30%, up to 60%. So it was basically like that kind of thing, but with the same size triangle.
So congrats on So maybe if there's any final comments for this team before we take a quick break and business section.
Any comments or questions from everyone else? Not from the other team.
Well, thank you.
The load is
Start to begin the second presentation. Again, be 15 minutes for the presentation and 15 for the questions. And then after the second group presents, we'll ask that just the jury to stay along and begin to go into the project deliberations to pick the final team to construct their project at Untitled City this summer. So,
All right. I'll start off saying that we are group 10. This is Sergio,
Nate, Andrew, and Andres. And the way we approached this project was from viewing it from a bee's perspective, not only any bee, but a bee from Buffalo and what he might think a habitat would look like. So even based on the site that we were given, Silo City, I'll breeze through this because a lot of you were here, but I do see a few faces I haven't seen yet, so I'll breeze through the presentation for them. The site we're given, Silo City, is surrounded by grain elevators, so that's something that really influenced our design in that project. So how can we come up with a design for bees, a habitat for bees that can respond to the site that we're in, respond to the grain elevators that have such significant value to Buffalo architecturally, economically, and socially. So just studying the form of these cylindrical shapes, we thought of ways in which we can derive a form that can start to communicate the same language of the cylinders, but at the same time, perhaps abstract it and sort of push forward in technology what we can do by using a cylinder, but coming up with a new method of construction. So we derived the form of the arch for this. We think it's a very sculptural element for the site. It could be a beacon for a lot of people to gather around, not only as a habitat for bees, but sort of a gateway or an entryway into the park that you guys are trying to develop. As for the site itself and the environment conditions around it. We first studied the traffic patterns and how we have this road on the north side and how we can start to attract visitors into the park. The wind comes from the southwest, so we thought of ways in which we might be able to diverge the wind or maybe somehow protect the bees on the inside from cold, harsh winter winds. Another thing we looked at, which Nate is going to get into a little later with Ecotec Analysis, is how the sun can start to define or orient this form so that because it's steel, it will heat up a lot in the summer. So maybe ways in which we can insulate that or even protect the bees in a certain way so that they get less summer sun, but in the winter they get more winter sun to keep it warm.
So this is a series of our Ecotec Analysis. We went through a couple of orientations, but we ended up deciding to stick with the northeast orientation, as you see here. This was just, and this shows what the sun path and the resulting shadows would be during the winter solstice, summer solstice, and the equinox. And we also kept this in relation to the wind, which was another factor in why we kept this orientation. We felt that this was the best orientation we could site the project at.
So another thing that we were thinking about with the elevators is how we can think of them structurally with the fact that they're hollow and they transfer grain, the same way of applying that technique to how we think of transferring bees within the shape. So by using steel, it's a thin material that you can use structurally so that in the end your project is hollow and it's easy for bees to inhabit.
So we're going to start off talking about dollars and the budget. We'll get that out of the way and we'll break the ice with that. So our structure really starts off with is basically a steel tube, structural steel tube that would be assembled in modules. So it has similar construction techniques, and you can reuse the same material over and over. Andre's going to pass out a sheet, just kind of shows like a little exploded axle of the assembly or the parts that we would assemble, and a rough estimate of the budget. We were quoted for the steel at either between $435 a sheet or $605 a sheet, depending on which steel we would use. And we would still use a stainless steel sheet. And then estimating what we could find for the other couple other materials that we need, such as concrete, bolts for connections, and bolts for the connection between the concrete and the steel, the plywood sheets, and 1/8-inch PETG. The grand total for just the raw materials was $7,013. We would like to keep the labor within ourselves and in-house at Rigidized Metals, and Andrew's going to talk about the construction.
Well, first I'll talk about these are our shop drawings of what will be plasma coated. So there are 3 thicknesses of sheet metal that we're using. The exterior panels will be 3/16 sheet stainless steel, and we were able to fit all that onto 11 sheets of 4x10 sheets. And then for the structural panels inside, that would be a little thicker, 1/4 inch stainless steel, and that's just only 2 4x10 sheets. And then we only need 1 4x8 sheet for the inch thick stainless steel, which would be bolted onto the concrete underground. And the plywood sheets, which we're using for the shelving for the actual bees, we'd only need 2 5x5 sheets and 1 5.5 sheet for the largest shelf. So this is just showing the different dimensions and the layout of the actual plasma sheets that we're using.
Okay, so I'm going to talk about actually how we would build it, the process, the order in which we would build it. And one of the things that we really want to do is, like, we really want to build this ourselves. We think, like, it's our project, we designed it, and why not build it ourselves? And we have a shop here, so we think it would be a good opportunity. So first we have 2 simultaneous construction things that would go on. We would have a few people on site, which would first lay out the rebar, and then we would have bolt anchors that would be cast into the concrete. So you can see here, this is what that would look like. And then we would also have, at shop here, we would have a few team members working on the first module. So we broke this down into 4 modules. So we have the 2 modules are the lower half of the structure. So how that would work would be, we would first have the steel plate, and then we would have structural gusset plates, and then we would first put on the 2 planar elements of the model, this face and the back face, and then we would actually, which is this drawing here, and then we would put on the interior face. We would either weld that or rivet that. This depends, the method in which we bond the pieces together is going to depend on whether it's something, if we can weld the steel, or if we can rivet it. Whichever one we could do, we think is the best, because we want to build it ourselves. So then we would put the interior one up first, but we would leave the exterior face open for later attaching the other module, the top module on. So then for the top module, it would be a similar process. We'd put the 2 planar elements on first, and we'd have a steel plate on the bottom, and we'd also put in the wood pieces, which are held in by these brackets that we would put on the planar pieces. And once we have that together, then we have the interior face, which we want to be removable. So these would be bolted connection. We would have some sort of a bended PETG 1/8 inch thick, which would be a clear see-through part, and that would be attached by these bracings that would attach to the structure. So then these panels would become removable when we need to get at the bees to care for them. So this is what the final top module would look like, and the bottom modules, and we would have these prefabricated and then brought on site. So on site assembly, really there's only 3 steps that we would need to do, which would just be bolting the 2 modules down, and then we would bring in the top module, and then the only welding that we would do on site are the 2 exterior pieces, which would finish off the sculpture. So this is a detailed section showing the 2 modules, showing the construction process for the planes is a folding process. So if I go back to that section, you can see that these are folded. These are what the folds would look like, and then we would either weld or bolt that to each of the pieces. And then these are the bolted connections for the upper and lower modules and how they come together. So this is basically just showing the concrete and how the rebar would work, and the steel ties and how the anchors would tie into that.
Actually, I can add to this for a second. These are the gusset plates that actually there's a lot of load going in this back corner right here. So there's a gusset plate on the inside, which follows this curve, and that load gets directly transferred into this one, which gets transferred into the ground. And then to kind of cover up that detail so that this thing seems more natural with the site, we just covered that up in another layer of earth.
So here A is, again, this is the connection joint between the two modules. Then in terms of ventilation, because one of the issues with this steel hollow structure is it's going to get pretty hot if we don't have some sort of way that the wind could circulate through it. So at C, we have the lower, we would perforate holes.
Which is
under
right here.
Yeah. And so that since this this is where the wind is actually coming from, the wind would enter in through the inlets on the bottom, and then they would rise up through the wood panels, and then they would exit out the top in order to cool the space.
So to add on to how we would assemble this, we're thinking of two options, and you can see in these two models, one is welded, and the other one is the riveting option. The difference between the two is obviously the labor cost that it would be to weld. It would like raise the costs a lot higher. So we were thinking of riveting, which everything could be done and prefabricated at the rigidized metals, and the folding and the holes would be done. And basically all we would have to do was just rivet each piece together, which is a very simple option, and this thing can be assembled fairly quickly.
And I think the reason why we're sort of thinking about these two things is because stainless steel is a very difficult material to weld. So we were told like people get paid $100 an hour to do this. So if it's something that we wouldn't be able to pick up right away, which I don't think that's true. I think we're a bright group of kids here. But if that's the case, there's going to be a lot of construction at probably rigidized, because we don't have the materials here to weld stainless. Or another really simple thing to do would be to just rivet the whole thing, which you would just need to punch out holes, and then we can do that all ourselves. Again, this is the HIVE system and the way in which you can remove these panels with a few bolts. And finally, that's our envision for the site. We picked out this coffee bean color to kind of reflect on the grain elevators, but we didn't find something that was textured in that color, but we're sure we can have a conversation about that. So if you guys have any questions, feel free to let us know.
Important too.
How tall is it?
A little over 8.5.
So a 6-foot person would be close to these.
Yeah, we have the actual where the beaks are exiting and entering is through the top part of this module. So the viewing is kind of directed towards the other side. So we're working with that as a way to sort of balance between like how close you can get to the beaks and then where the beaks are actually entering.
And the hive actually could potentially come all the way down to here. That's where we stop the wood panels. So that also, you can get really close to them, but the fact that they enter and exit from the back of the model to the highest point, that kind of gives you a sense of protection. Whereas you do kind of feel intimidated by how close you are when you're standing right next to it. From the southwest, so from this side, look up this way.
The other thing that I did forget to mention was we were planning on using spray insulation as another means of regulating the heat or the bottom of the structure becoming too hot in the summer or getting too cold. Well, spray insulation is, I think it's pretty simple to put on, so it would just be like around, we would build the whole thing, but it would be like on this face here where the sun is hitting it, and then
interior?
Yeah. And actually, I think it might be easier to just spray that on once you get the panels out, and then assemble it. So that's also something that can be done fairly quickly.
What thickness is that like?
The thickness of
this bracelet. Is it small?
Oh no, it's thin. Yeah. It wouldn't be like different types of insulation like that, 2 inches. It'd be something fairly thin that you can drill into and still manage the material so as it wouldn't ruin your calculations. Because it can work.
What material is that? Is it spray foam? What material is spray foam?
I'm not sure. Someone researched that, and I forgot what it was, but we read that it didn't really harm the chemicals in it, and they weren't harmful for bees. I forgot what it was.
What sizes are your entry holes for the bees? One of the questions I have is more for Philip. It's you know, the bees naturally like to go in through this fiberboard or wood right now, and usually these things are wood. Is there going to be a problem for the bees because going through steel openings or those kind of things? I'm sure the answer.
Entry and egress, I don't think that you guys have talked about that.
Yeah, I remember we had more holes, and you said they're fine. It's just 3 holes
Yeah,
close to each other.
small, close together. So just trying to get the perspective of the bee, I guess. So that top part is going to be insulated, and the entry face will be insulated.
Yeah, but we would like drill through the spray.
Most of the installation.
Yeah.
And then, can you go back to the removable panels for a second? So, panels, the detail, yeah. But that looks a little
This is actually the
different than what's in the other one.
Yeah, this was the old proposal, but it's working the same way. I mean, the panels are.
Go back to the one that you had in the proposal.
Yeah, if you go to handout, that would be actually what they look like, as opposed to the triangulated system.
Okay, and this thing, so I'm not just taking this, but taking this whole thing.
Yeah.
And that's the whole thing is bolted in. And we talked, there is trick, they can get through each and all of those.
Yeah, if you look at the cuts here, it's kind of small, but these C parts are where this is gathered. It's actually like a gap in the structure.
And the height of each of those again?
It's like a foot and a half.
That's not that big.
Yeah.
Plywood.
Yeah. Yeah, so this is the wood going onto the surface, up to the very edge of this field, and you can see here, we cut out a corner so that the bees can travel all the way through every single piece of wood from top to bottom.
And that's also where the glass face is, so when you come up to it and approach it, you can see the bees.
So the idea is that the bees build honeycomb on the glass, like the...
Well, we were actually thinking that since the rest of the reason why these are wood, that they're actually built on the wood. Okay. And we also, you know better than me, but we read that they usually start from the top down, so that's why they're horizontal as opposed to vertical.
Did you answer the question whether or not going through steel would make a difference?
Yeah, Philip said there's no, as long as the size of the hole, ought to be all right.
So the temperature, if it changes temperature, it doesn't make a difference?
Well, that's the only, that was the question, but that you talked about the spray insulation.
But the metal will still change temperature.
Yeah, the exterior will still change temperature. You know, you might have to put like a wooden collar around that whole part, but I don't think that should change your design too much.
Yeah, we had holes. We were thinking holes would be punched out, but this actually might work better for that, is that if we have a larger square punched out, with holes in it, as opposed to this thicker piece of metal, which might heat up more.
Or you can put an animal wood. Just a small animal wood.
You guys talk a little bit about, so this is a weather type. Water's not meant to penetrate or anywhere in the scheme, is that correct? Then how have you started to think about how you make that joint, which is right now metal on metal, right? Any thoughts about, well, also the way moisture condensation might build up? Potentially ways, this might be a rhetorical question at this point, but for both, maybe more so in this scheme because you're trying to make a weather tight enclosure in the whole thing. How moisture tends to kind of like exit when it builds up on the inside. I think there are solutions for it. Probably we can start talking about that.
Where we kind of along with that first picture, there was the bottom part of the top of the module.
Yeah. Yeah. Yeah, so the entry ventilation holes will be here, but yeah.
That's where it disappears over the curve.
Yeah. We were thinking that they would not exit from this because that's the one close to the bottom, so that's what would have the mesh so that they can't go in and out of. And this up here would just be clean holes so that they can't exit through the top.
Back to what Chris said, I think a solution to like how the water could travel, I mean, this actual shape itself is going to naturally want water to flow down this way, so I think some sort of mesh or something and use on the plates to allow water to just like flow through and down and maybe out. Right. The other thing is that we could think about like where the fold overlaps. We could have some sort of vapor seal there as well.
What did you say the finish was? The finish on the...
You can, it's this coffee bean glass. And it's actually not textured because we didn't find a sample that had that color but was textured. But eventually we would want to have something that is textured to give it more rigidity.
So the sample was provided by very good subcontractor.
Can you talk about why you want to use the live finish? You seem very particular about it. You want to
Yeah.
a raw finish.
That was something that we've kind of been trying to push for since the beginning, was reflect this sort of this rustic idea from the grain elevators onto the site and onto the park. And originally we wanted to use Corten, but that gave us a lot of difficulties welding and actually finding it. So we still want that look, we still want that color, and that's the reason why, pretty much the reason why we've been pushing forward with that. We think it gives we think it feels more natural to the site as opposed to like a shiny, bright silver sculpture.
Almost like a simulated one.
And you know, the metal stuff is that, you know, there is reasons for stainless steel. There are reasons for colloidal carbon steel. There's reasons for galvanizers. There's a whole bunch of different realms. And Corten is a sort of, in my mind, it's an over-engineered solution that sort of gives the natural. If you use just colloidal carbon steel, then you have the same sort of organic rusting that will occur, and it won't look like it's been there for 40 years today, but it will look like it will age. You know, just like copper, patinas, or patinas, whichever pronunciation you guys like. But there is a good way to do that without using the sort of the Corten stuff.
Yeah.
So you can change the material from being a shiny thing to a colloidal carbon steel.
And then
Get that
well,
yeah. So it's
We have about 3 minutes left.
Do you have any other comments? Yes. No, that was it.
well, Brian begins with B. I have small children, sorry. Did you guys have a lot of help from the structural guys?
Yeah, they gave us a lot of the basic structural ideas for like, how this bot, a lot about how the bot would work so that it would tip over.
Yeah, specifically we had like 2 major structural issues that we had to tackle was how this thing met the floor. Actually 3 things, how this thing came together with the floor and how the weight was distributed onto that foundation with these large custom plates, which was something we didn't have previously, and then how the 2 modules came together.
I think it's very, very clever, the design using concrete. The idea of bolting those together, that's going to be interesting. Just, I don't know the sheer strength of those kinds of things, but I think you did a very good job with the structure. Those bolts, they're going to be the weakest link things for the structure, so it's just making sure that those are
we were told
designed properly.
We would use 1-inch bolts, and we were told that they're very structural and very powerful. So that's the connection that we have there.
Just as Jim, the 90-mile-an-hour breezes are tough down there, and I over-engineered that one connection.
So does the structure form a conspicuous gateway to something?
Well, we don't know what the park is looking like. We don't know what the ideas are for that, but eventually we do want it to either be an entryway or a gathering point of some sort. So depending on what the architecture plan to do with the site, we can easily see it as the center of the park, or maybe even the entrance to the park.
What is the distance between